To wrap up this section, I'm going to talk about factorials and sigma notation, or a little bit of series. So let's run back through factorials. Now hopefully you've had some experience with these in the past, but 6 factorial would mean starting with 6 and multiply by every countable number down to 1. Eventually we're going to get into some reasons why you can't keep going with 0 or negative numbers there, but probably a quick way to answer that is as soon as I throw 0 in the mix, the whole thing's 0 and it's kind of a useless process. So it's 6 times 5 times 4 times 3 times 2 times 1. That would be 6 factorial. And that's the idea. These show up a lot in countable situations. Anyway, I'll leave it at that for now. For this example, I'm going to list all the terms out so you see everything. Normally when I'm working these out in class or by hand myself, I'll say like 6 times 5 dot dot dot. So I kind of see the pattern. But again, I'm going to work everything out for now. So 6 times 5 times 4 times 3 times 2 times 1, that's 6 factorial. And then 5 factorial will be 5 times 4 times 3 times 2 times 1. And then 3 factorial will be 3 times 2 times 1. And now it's just a matter of, let's see what crosses out. What's in common? So we got a couple of 5s, 4s, 3s, 2s, and 1s. And again, the reason I like to say something like 6 times 5 times 4 dot 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 is because I know that everything from 5 down will be the same as 5 factorial and all that goes away. Other stuff that can go away, well 3 times 2 is 6 and that can be divided out. So don't forget, when everything goes away on the top, technically when I say divide out, this means they become 1. So that is still 1 on the top, 1 on the bottom. So the final answer there is 1. Then you're going to have some problems where you have to have variables involved with your factorials. So it's really important that you understand the pattern to it. So the way this would look, n plus 2 factorial starts with n plus 2, and you're going to count down by 1. So subtract 1 from this, it would be n plus 1. Subtract 1 from that, it would just be n. Subtract 1 from that, it's n minus 1. And that's going to continue all the way until you get to 1. On the bottom, it's n factorial, so that's going to be n times n minus 1 times n minus 2, all the way until you get to 1. And now it's just a game of looking to see what's in common. Well, we've got n on the top and the bottom, n minus 1, and it turns out that everything from n minus 1 to 1 will be in common on both lists and divide out to be 1. So all that's left here is n plus 2 times n plus 1, and I'm going to go ahead and combine that together. Middle terms would be 2n and 1n, and on the end 2, and there we go. That's as far as we could take that. Sigma notation, this is up to doing some series now. This will produce a sequence and these terms will be added together. A lot of students that just cringe when they see sigma notation, but once you get used to where everything goes, it's really not bad. It's pretty straightforward. So just to recap of how it works, this is your formula that you're going to plug into. You're going to begin with the number on the bottom plugged in for the variable given. So k is 2, that's going to go right here. And you're going to continue plugging in numbers for k counting up. So we'll do 2, then we'll plug in 3, then we'll plug in 4. And then we'll stop when we get to this top number. As soon as 5 gets plugged in, that's where we stop. The most common mistake is for students to think, all right, I'm going to have 5 terms here because there's a 5. That's not what it is. It doesn't mean start with 2 and do 5 terms. It means start with 2 and stop when 5 gets plugged in. So we'll get into how to figure out the number of terms from that as we go through homework problems. I'm going to let y'all kind of mess around with it and find patterns. But just don't fall for that. Be careful with knowing you stop when this number gets plugged in. So let's run through and see how it's going to go. I'm going to write this out really longhand. I really wouldn't do this on my own work. So you can do it quicker if you're okay with it. But just so you see everything that's happening, I'm going to really write this out longhand. So the formula is 3 times k. First up, 2 goes in. And then minus 1. All right, so that's one term. Plus the next term. Now the next term is I count up to 3 and plug that in for k. So 3 times 3 minus 1. And then 3 times 4 minus 1. And then when I get to 5, I'm done. So 3 times 5 minus 1, that'll be where I stop. So let's see what these come out to be. 6 minus 1 is 5. 3 times 3 minus 1 is going to be 8. That's 12 minus 1, so that's 11. And really, once you do 2 or 3 of these, you can usually see the pattern. Usually about 3 you can see the pattern. You'll also learn to know what arithmetic sequences look like based on the formula and geometric sequences based on the formula. Once we cover those sections, then you'll have some more shortcuts you can use. But for now, let's just do it longhand so you get the idea of how sigma notation works. All right, and that's going to be 15 minus 1, so that's going to be 14. And it's just a matter of adding these all together. So 5 plus 8 is 13, 11 more is 24, and then 38.